A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be discussing a very important topic, that is correlation and regression. Often there is a doubt in the researcher's mind that what is correlation and what is regression. So, I will define correlation and regression in very simple and easy terms along with an example on how to calculate the coefficients of correlation and regression in Microsoft Excel. So let us start. Correlation is defined as the strength and direction of relationship between two variables. It is depicted using Pearson's correlation coefficient, which is small r and ranges from -1 to +1. 0 means absence of correlation. -1 means extreme negative correlation and +1 means extreme positive correlation or perfect positive correlation. By negative correlation, I mean that if the value of one variable increases, the value of other variable decreases by the same amount. Then it is called as a linear negative correlation. If the value of one variable increases by a certain amount and the value of other variable also increases by a certain amount, then we call it a positive linear correlation. Regression. It assesses the proportion of variance in dependent variable which is explained by independent variables. As I told you in the last video that a linear regression has one independent variable and one dependent variable, whereas in multiple regression we have several independent variables and one dependent variable. Coefficient of determination R square, which is the square of Pearson's correlation coefficient, tells us how well the data fits the regression model. Here we are seeing three pictures where the horizontal line depicts the x-axis and the vertical depicts the y-axis. So on these two axes, if we plot one variable on the x-axis and one on the y-axis and there is a straight line, that means it's a positive correlation. When there is no correlation, we see a line going parallel to the x-axis, which is shown in the second figure, the middle figure. When there is negative correlation, as I told you, when the value of one variable increases and the value of other variable decreases, it's known as negative correlation. Regression equation, it's quite important to know how do we compute regression equation. In this equation, x depicts the independent variable, y depicts the dependent variable's value, which is predicted using this formula alpha plus beta x. Alpha stands for y-intercept, beta stands for slope or regression coefficient. It tells us the proportionate change in y for every unit change in x. Now let us go to Microsoft Excel and look into a very simple example so that you remember it forever, that what is correlation, what is regression, and how can we easily compute them using Microsoft Excel. So here we are in our Microsoft Excel and there is an example on predicting student scores, which is the dependent variable depicted using y based upon their study hours, which is an independent variable x. We want to predict the exam score based on hours studied using linear regression. Now, first of all, using the same data, we will try to find out whether there is any type of correlation between the number of hours spent on studying by a student and the score they have scored in their exam. So we'll find the correlation between these two. For this purpose, you go to data and then you go to data analysis. Now, how did you get this data analysis? I'll just show you right here. You go to files, you go to option, and then you click on add-ins. And when you click on add-ins, you see here Excel add-ins. Just click on go, and here you see analysis tool pack. Just tick on this and press OK. That is how you will get this data analysis under the data tab on the right extreme side panel. We'll click on data analysis. We'll go to correlation, click on OK. And now in the input range, we'll put the two variables for which we want to take out the correlation. There are 20 values you see, and I've entered the range from B3 to C23, grouped by columns, labels in first row, output range. When I click on output range, so I'll get the results in this column, and then I click OK. So this is what I've got. I've got the correlation coefficient, which is R. It is 0.944. That means there is a strong positive correlation. There is a strong positive correlation between number of hours spent on study and the score in the exam. Now we look at regression. How to do regression? Again, go to data analysis, and this time I'll click on regression and click on OK. And for the input range, that is y variable for which you want to predict the value using the regression equation. Y is equal to alpha plus beta into x. That is the regression equation. So here, exam score is the dependent variable and independent variable is number of hours spent on studying. I enter them like this, then I click on labels, output range. Again, where do I want it? I can click anywhere. If I click over here, you see I'll get the results in this column. Then I click on residuals and click on OK. So now I've got the results for my regression, which I can use in my paper, in my dissertation or my thesis. Now R square, which is the coefficient of determination, is 0.89. That means 89% of the variability in the exam scores is contributed by the number of hours spent on studying. Right? Now we'll go to ANOVA table and we'll see that this significance F value will show us whether there is a statistically significant regression. We just click on this, go to format cells, number, increase the decimal places. So I increase the decimal places to 12 and now see, yes. So if this significance value is less than 0.05, at 95% confidence interval we are conducting this test. That is why significance value has to be lesser than 0.05. So here in this case it is quite less than 0.05. So we can say, yes, the regression is significant. So The influence of independent variable on the dependent variable in this regression analysis is quite significant. Now we see the p-value. So again, click on them, format cells, number, increase the decimal places, and click on OK. Now you see here, again, the p-value is lesser than 0.05 for the intercept, and R studied again lesser than 0.05. They both have to be lesser than 0.05. Now we'll put these values in our regression equation. So our regression equation was y is equal to alpha plus beta into x, right? This was our regression equation. 37.29 plus 5.34. So we are going to add up the coefficients. 37.29 plus 5.34, and x is, what is x? R's studied, right? So this is a regression equation which we have made. Now we can use this for predicting the value of y. We can use this for predicting the value of our independent variable, which is the exam score. Quite interesting, right? So if we see the residuals are basically the errors which we get by subtracting the predicted value from the observed value. This equation shows us if we increase the number of hours studied by 1 unit, then the exam score will increase by 5.34, which means that if we increase 1 hour of study, then the exam score will increase by 5.346, right? We are going to use this equation to compute the predicted value of y. So number of hours studied, let us see the first of students' observations. R studied is 2, exam score is 50. So R studies is 2. So we'll put here 2. So what will we get? We will get 37.29 plus 10.68, which is equal to 47.97. So the predicted value of y is 47.97. Now this is the predicted value of y, and the exam score y value, the observed value, was 50. So what is the residual? Observed value minus predicted value. So in this case, we have 50 minus 47.97, which is equal to 2.01. And you see here, the same we have got it in the residual output for observation number 1, 2.014, right? The one which we have calculated it over here. So I hope you have learned how easily we can compute correlation and regression in Microsoft Excel. See you next time. with some great new content. Till then, keep learning, keep watching for more. Thanks a lot.